Howdy all, and welcome back to Chapter 9, Lesson 6. I say sort of Lesson 6. If you'd like to look at it, you'll see there are some helpful things in there. But otherwise, we're going to talk today about scale drawings, scale, and scale factors. And in fact, you'll see that vocabulary, we'll be talking it through. A scale drawing, a scale model. Simply the word scale, what does that mean? And how is it similar and how is it different to a scale factor? Some more on that. If you need, take a look at the assignment, whatever the assignment is for page 243. Pause, check your answers. Come on back when you're ready. All right, ladies and gents, our goal today is threefold. We will hope to solve for unknown values in scale drawings. We will find or identify the relationship scale and or the scale factor. Again, we'll talk about the difference between those. Furthermore, we will use those to construct similar figures. Now think about everything we've done with our cross products and ratios. So we're going to use that skill to say, well, let's say we have something on a map. We got Rosetown to Flowerville. We know they're 2 and 3/10 centimeters on the map. And we also have a scale. What we're going to be able to do is use our cross products to then find that missing piece. How many miles in real life? And we'll use a similar idea to eventually solve more complicated percent problems. All right, you might want to fill out a piece of paper. Our goal today, our homework assignment, is actually a worksheet, and there's probably not going to be enough space to write notes on that. So you might want to go ahead, get out a piece of paper, and let's get into some examples, shall we? All right, let's talk vocabulary for a second. Using scale drawings. Now, let's say the dimensions of a scale model or a scale drawing, there's that word. They are proportional to the actual dimensions. In fact, scale drawings are either enlarged or reduced, but it's always going to be similar to the actual. I usually set up a relationship of new to original. So keep that in mind. In fact, that might be the most important thing to write down. Now, of course, if you don't change the photo, it would be 1-to-1. But that's not really changing things, so you almost will never see a scale of 1-to-1. If it's reduced, you can imagine a number that's less than a whole. So you might have a ratio of 1-to-2. Or maybe you have a ratio of 1-to-10. However you write those ratios. On the other hand, if it's enlarged, you can imagine then the opposite effect. It would be greater than 1. So for instance, you might have 4-to-1, or you might have 20-to-1, in terms that the new guy is much larger than the original. All right, let's keep that in mind as we go into this problem. Here, our final goal is finding the actual distance between Daytona Beach and Orlando. Now, interesting, we look at the scale, and I'm sorry this is a little blurry, but the scale is 1/2 inch on the map is equivalent to about 17 3/10 miles in actual life. So basically, you can just get out your ruler, set it up, and when we did that, we found that the distance is 1 3/4 inches away. You can write that as decimal, you can write it in fraction or mixed number form, it's up to you. So here's what we have. We know that on the map, it's 1 3/4 inches away. How far is it in actuality? Let's go ahead and set up the ratios. The first thing you'll notice that I do is set up those ratios with inches to miles. Let me get rid of that. So what do they give us? They said that 1/2 inch is the same as 17 3/10 miles in real life. Now, where am I going to put that 1 3/5? 1 3/4, excuse me? Well, that's inches. In fact, it's the map. And we set up the map to the actual, just like the map is kind of the new guy and the actual is kind of the original. And there's our missing piece. So from here, we've set a proportion and we know how to solve these. We're simply going to take our cross products. We're going to multiply 1/2 times d. We're going to multiply 17 3/10 times 1 75/100. In so doing, we get about 30, but we don't want to know what 1/2 of d is, so we divide both sides by 1/2. Any number divided by itself gives us 1 whole, and that's precisely what we wanted, 1 whole d. 30 split up into half is about 60. And so the actual distance between Daytona Beach and Orlando in real life would be 61 miles. And if you'll forgive me, I know I need to do a better job of coming up with estimates. And so I should try to do a better job in the future of estimating to think if, just to decide if my real number looks reasonable. All right, let's do another one. If you'd like, pause the video, come on back when you're ready. So in this case, we have a scale that each half inch is equal to 14 miles. So whether you write new versus original, whether you write map versus actual, I would always suggest you write the units. Here we're comparing inches to miles, so I'm going to write it as such. They give us an amount, 5/10 of an inch, half an inch, 14 miles. And they furthermore tell us on the map, the distance between these two cities is 1 5/10 inches. Now, as soon as I see that inches, I know where that 1 5/10 goes. In fact, the question, what is the actual distance? I'll go ahead and use an A. So from here, we go into our cross products. I usually do the term with the variable first. So a half times A is going to be equivalent to 1 1/2 times 14. Now, I don't know what a half times A is. After all, A is an unknown amount. What I do know, 1 1/2 14s is 21. Oh, there we go again, Mr. Callan. Go ahead and make your estimate. So from here to here, I don't know, making it 20 times, so maybe 30 miles, maybe bigger. All right, let's get back into our solving, shall we? I don't want to know what a half A is. I want to know what a single A is. So let's divide both sides by a half. And don't forget, anytime you're dividing by a decimal, let's go ahead, change that divisor into a whole number as long as you're fair. And in this case, I'm seeing 42 miles, which is a little larger, but still not a bad estimate of 30 miles from the start. Anytime you're concerned about your answer, you can come off to the side. You can rewrite your ratio, this time substituting in what you believe that answer to be. And if you'd like to, you can either divide, you can use cross products, you can do this in a couple different ways. But if we were to divide a half into 14, if we were to divide 1 5/10 by 42, you will get the same answer. Shoot, I'll even show you a different method. Change 1/2 to 5, change 14 to 140, change 1 5/10 to 15, change 42 to 420. So this is simply us multiplying numerator and denominator by 10. And guess what? Both of those are going to reduce to the same quantity. 5 over 40 reduces to 1 over 28. 15 over 420. 1 over, yeah, it is the same. So you can always check yourself. Pause if you need. Go on back. Otherwise, we shall continue on with another example. All right, here we go again. Scale drawing of a map, 1 centimeter, 130 kilometers. The distance from New York to Detroit on the map, 5 8/10 centimeters. What is the distance as the crow flies, which is an old expression which basically means, yes, I know, if you're driving, you oftentimes will take a weird, but as the crow flies means you go straight there. So we just want to know what is the actual distance between those two. Again, new to original, map to actual, in this case, centimeters to kilometers, which sometimes Americans pronounce as kilometers. Our ratio given originally is 1 to 130. 5 8/10 centimeters, I know that the new or the map distance is given, and we're looking for the actual. Now let's go ahead into our cross products. 1 times x is quite nice because that's just going to give us exactly what we want. Meanwhile, The other product, 130 times 5 8/10, doesn't matter which way you do. Now, 1 times x is x. So really all we need to do is multiply 130 times 5 8/10. I'm going to go ahead and do that for you folks. I believe you can trust me. Oh, Mr. Callan, you forgot to estimate again. But quite honestly, this is about 100 times bigger. If that's about 100 times bigger, it's 580 or 600 kilometers, and 754 is pretty close to that. Again, if you'd like, you can come off to the side. You can either divide or reduce those, and in doing so, you'll find that those will be the same amount. They will be proportional. Let's do another. Pause if you need, read it, come on back when you're ready. All right, 1/4 of an inch is actually 2 miles in real life. Fire station of the town hall, 3 1/8 inches apart on the map. Question, how far apart are they really? So again, new versus actual, map versus original, or inches versus miles. 1/4 of an inch to 2. 3 1/8 inches to what? Let's go ahead and estimate before Mr. Callan forgets. So I don't know. Look at those in comparison. It's more than double. It's more than, what is that going to be? Times 8 times 8. That's about 8 of those. So 3 times 8, about 24 miles. That's my estimate. Let's see how we do. Let's go ahead into our cross products here, where we have 1/4 times x is the same or equivalent to 2 sets of 3 1/8. Now there's no need to mess with the 1/4 times x, but I'm going to go off to the side. I'm going to rewrite this as 2 wholes. Change 3 1/8, rewrite that as 25/8. With a little cross reducing to make our lives easier here, 2 goes into 2 ones, 2 goes into 8 4 times. And so we end up with 1 times 25, 1 times 4. Now I could rewrite that as a mixed number. However, I think you'll see pretty quickly why I will choose not to rewrite it as a mixed number yet. Now, many of you going a little old school, you'll go with the 1/4, divide both sides by 1/4. And if you divide 25/4 by 1/4, you're going to quickly remember that there is no division in the dividing of two fractions. Instead, you're going to flip that. I would say that many of you will immediately go to that multiplicative inverse. If you multiply both sides by 4 wholes, you are being fair. Meanwhile, you'll quickly see why that works. We end up with 1 whole x, which is precisely what we wanted. And 25/4, whether you see it right here, whether you see it right here, you're going to end up multiplying by the same. So 4 goes into 4 once and once, and we end up with 25 wholes, which I suppose you could write 25 wholes, but you're just going to write it as simplest form anyways. And notice that is pretty close to our estimate of 24 miles. So that was a great estimate and good skill to find it. Now, if you would like, you can go ahead and pause the video, start up the front side, and perhaps in a minute I'll show you what 1 or 2 of the ratios will look like. So pause, come on back and see if you've set it up correctly. So here we have 1/3 of an inch to 2 miles. The real thing is 2 inches. What is the actual distance? Go ahead and solve that, find out which one of those is the correct answer. Take a look at number 5 real quick. Let's go down to number 7. Number 5 is another inch to miles. Number 7, this is interesting. 1 to 90, but it doesn't give us the units. Actually, it talks about scale factor, which we're about to talk in a second. So I guess the question is, new to original, what is given us here? Well, the actual tree is given to us, and we're looking about how big the model should be. So in this case, we don't know what the numerator is. We do know what that denominator is. Now you can go ahead and use that to solve and find out what x is going to be. All right, so onward today. We're going to get to this We might choose, you should be able to finish the front side by now. Let's get to that back side. Let's talk more about what scale and scale factors mean. A scale factor is a special scale. It's a special ratio in which the units are always going to be the same. Now, it could be enlarged, it could be reduced. We've talked about this before. You'll see this similar in actual. A lot of times Mr. Callan calls that new to original. We've talked about that. So a scale factor is the ratio of a scale drawing or model to the actual length, corresponding length of the real object. And notice what's in red. So maybe that's the most important thing to write down. If you're looking at a scale, it can be different units, inches to miles, centimeters to kilometers. But if you're looking at a scale factor, it's got to be the same units. Take, for instance, I'm giving you a scale of 1 inch to 2 feet, and I've written that as such. But a scale factor must have the same units. So let me change these both to inches. 1 inch does not change. 2 feet is the same as 24 inches. And so the actual, while the scale of 1 inch to 2 feet is written with different units, the scale factor, and notice I didn't have to write 1 inch to 24 inches, it does mean the same thing. So that's the difference between a scale and scale factor. Scale can have different units. Scale factor must be the same. In this case, you can say that the actual length is 24 times the model, or vice versa. You can say the model is 24 times smaller, 1/24th the size of the actual. I've used this analogy before. Remember that every square is a rectangle, but not every rectangle is a square. In like manner, every scale factor is a scale, but not every scale is a scale factor. Scale factors must have the same units, where scales may or may not have different units. The example we just used was inches to feet. That's a scale, but inches to inches or feet to feet, that would be a scale factor. I'm going to give you an example, and I'm going to do this 2 different ways. Let's find the scale factor of a model sailboat if the scale is 1 inch to 6 feet. Now I'm going to write this 2 times. Firstly, I'm going to change it to inches, then I'm going to change it to feet, and let's find out how that affects scale, shall we? All right, now 1 inch will not change. 6 feet, if I were to multiply that, each of those 6 feet is 12 inches. So I do believe I've just found the scale factor. You can write it like this. You can write it like this. It doesn't matter to me. All right, now let's take a look at the bottom. 6 feet does not have to change, but how do we change inches to feet? Well, each of those inches is the 12th of a foot. So 1 inch is equivalent to 1/12 of a foot. Now what I'm going to do is I'm going to rewrite this old school. I'm going to write 6 holes, and I'm going to say, wait a second, how do I divide by 6 holes? It's going to be the same as multiplying by 1/6, and we get the same answer. Ultimately, what you get to decide is, would you rather choose to keep the smaller unit or the bigger units? Now, I have a hunch that many of you will choose the smaller units all the time because you won't end up with a very funky, complex fraction. But some of you might be more comfortable changing complex fractions, and others of you just like a certain unit better, and that's fine, because after all, they're both the same ratio. They're both the same scale factor. So you get to decide. All right, let's do this one. What is the scale factor? That's what the question's asking. Oh, scale factor, alarms go off, got to be the same units. We have a model of a sports car that says 10 centimeters is equivalent to 3 meters on the actual car. Most of you, I'm going to guess, are going to go with the smaller of the 2 units. That means the 10 may stay put, But each of those 30, okay, how many centimeters in a meter? Well, you know cent means 100. So each of those 3 meters is going to be equivalent. All right, 3 meters is the same as 300 centimeters. Let's go ahead and reduce by 10 to find a final scale of 1 to 30. Yes, you may write it in that way, or you could even write it with words. Noticing that the actual car is 30 times bigger than the model, or you could say the model is 1/30th of the actual car. That is the nice piece of using scale factors. It'll tell you the precise size. Now, example 3 is twofold. A, we want to find the scale factor, and then B, we want to find the length of the model. Now I'm seeing a scale, excuse me, down here. It's a scale because the inches are different than the feet. We can convert that into a scale factor. I'm going to suggest most of us will change to inches. So the 2 does not change. 15 times 12 will change. So 15 times 12, I trust you guys can take care of that. It's going to be 180. Reduce by 2, if you please, to find the scale factor of 1/90th, as in the model is a 90th of the plane or the plane is 90 times. Okay, find the length of the model. If we know we got 87 feet, we can multiply not by 90 wholes, by 1/90th, and we're going to get 87 over 90, which, by the way, reduces by 3 quite nicely. 29/30ths of a foot. And yes, you could change that to inches if you like. So again, step 1 was to use the scale, inches to feet, to find the scale factor, inches to inches, or sorry if the microphone muted out. In that case, the scale is 1/90th. Then we can use that scale to say, all right, what is given to us? By the way, if they gave you the model, let's just say the model was 2 feet, which would be a very big model. Instead of multiplying by 1/90th, you'd multiply by 90 wholes to find the actual. Now, we can further use what we know about comparisons when we're talking about shapes. Always comparing the new to the old. So if the new one, how many times bigger is the blue shape? So we're comparing the old guy to the blue guy, the red to the blue. 10 to 5 reduces to 2, and 8 to 4 also reduces to 2. So it's frankly 2 times bigger. And you can use that, the scale factor. If you didn't know one of these, you could say, oh, come on, if the scale factor is 2 times bigger or 2 wholes, then you can use that to actually find the missing piece. In like manner, what if it's getting smaller? What if it's reduced? Well, you're still going to set up new versus old. In this case, 2 corresponds with 6. Maybe I should have drawn the arrow the other way. 2 to 6 reduces to 1/3. In like manner, 3 is the new, 9 is the old, and that also reduces to 1/3, which means that the scale factor is 1 to 3 or 1/3. So if you were to be missing one of those pieces, and you know this is 9 to 1/3, you can do the same thing here to find what that missing piece is. All right, let's practice that. What's the scale factor? Take a moment and then come on back. It does say left to right, so we're talking 5 to 15. I like to draw the arrows just so I don't make a mistake on that. So the new guy is 15, and that corresponds with 5, or you could have written 21, that corresponds with 7. In either case, we can say that the scale factor is 3. You can write it as 3 to 1. You can write it as 3 to 1. But the new figure is 3 times the size as the old figure. Now this just kind of reviews. If it's enlarged, that scale factor is going to be larger than 1. If it's reduced, well, shoot, that scale factor better be smaller than 1 whole. Let's do one more problem. I think what we just did is we just took care of 11 through 20. So I'd like us to pause and to go to 21. And this says we're going to we're sketching a new figure with the requested scale factor. So we're creating our own figure B. Scale factor is 2 wholes. Okay, well, wait a second. I'm going to write figure A. It looks to be 1, 2, 3, 4 units tall. 1, 2, 3, 4, 5, 6 units. And we can use that scale factor, ladies and gents. If it's more than a whole, I'm expecting something bigger, right? So we go ahead and multiply by 2, we multiply by 2. And so our new height is going to be 8. 1, 2, 3, 4, 5, 6, 7, 8. And our new width is going to be 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm going to go ahead and complete the figure and label it rectangle B. Noticing that rectangle B must be bigger, noticing that each of those widths are precisely double or twice the amount because the scale factor was 2 to 1. All right, now in class, we might be splitting this up into 2 days, but now you should be able to handle the whole assignment. Front side was simply setting up scale factors and using those scales, to solve for missing pieces. Back side is going to look like this, where you're either finding scale factors or creating new figures. All right, folks, that was a long one, but it was important. I hope you do well. Take care, do well, let's grow. See you.